Now class C. So class C is even more. The conduction angle is going to be very, very less. So it will conduct only for less than 180. So less than half of the cycle. So that will mean the efficiency is going to be very, very high. So you can see here you have a negative bias VB to ensure that the transistor is going to be off for majority of the time. And only when this input is more than this bias, this amplifier will amplify. And since the circuit is going to be highly noisy, you will have a filtering network to get the required signal, and 50 ohms load is there to get your output amplified signal. Okay, so this negative power VB, negative supply VB is going to keep my transistor majority in off time. And only when the input is more than VB, I have amplification happening. So you can see here, it is less than 180. So 180 is this full time, and you can see it is less than 180. So remaining time, it's going to be off. Okay, that is what is given in the diagram. So distinction between class C and class B is the conduction angle. As conduction angle decreases, the power dissipation will reduce. And the power dissipation is reducing, the output power is going to be less. When the output power is less, the non-linearity will be high and the efficiency will be high. You can see class A stands at 50, class B stands at 75, class C stands close to 90. And the efficiency in terms of conduction angle is given eta equal to 1 by 4 theta minus sine theta. You can use this formula and put theta equal to whatever conduction angle, pi or pi by 2, like that. You can put the conduction angle and you can find out the efficiency. For class A, theta will be equal to 2 pi. For class B, theta will be equal to pi. For class C, it is less than 180. You can put any value less than 180 for class C, and you can find out the efficiency. Eta will be very, very high. So this relation suggests an efficiency of 100%. When the transistor is not conducting, you will have an efficiency of 100, which is going to be the case of class C. In class C power amplifier, the efficiency is going to be 100%. And output is low. Output power depends on the conduction angle theta. And you can see that as the conduction angle increases from 0 to 360, the output power will also increase because the transistor becomes more and more linear. So as the conduction angle increases, the output power increases significantly. In other words, the harmonics will start reducing and the transistor becomes more and more linear. So in modern case, class C has been replaced by other efficient amplification techniques, because even though class C has 100% efficiency, it is not used because it produces unnecessary non-linear harmonics in your signal.